Greetings. The topic of my research is certification of digital content based on NFT technology. The purpose of the research is creation of a unique platform for certification, purchase, sale, exchange of digital content in the form of NFT, ensuring the ability to protect the information of digital certificates containing confidential data. The object of the study is the process of certifying digital content in NFT by endorsing the key snarks and cryptographic encryption. Research subject is technologies for the development of a platform for certification of digital content in NFT, copyright protection of digital content. In today's digital world, where data privacy and security are becoming key properties, innovative methods of certifying digital data without disclosure are coming to the front. Blockchain technologies are not limited to protecting digital assets, but can also be effectively used to create secure certification systems. Thanks to blockchain, it's possible to create certificates that not only guarantee the integrity of data, but also ensure its tracking and authentication through a distributed and secure network. In the context of development of digital data certification in NFTs is noted not only as a tool for unique digital assets, but also as a potential technology for certifying private data. However, today, such innovations have not yet been widely used, which raises important questions and challenges. The problem is the lack of effective certification mechanisms that can ensure a high level of confidentiality without exposing the metadata of digital certificates. This limits the possibilities for improving the protection of confidential data, especially in areas where a high degree of trust and security is required. The introduction of innovative approaches to certification, including the use of the key snarks technology, encryption, and NFT certificates, opens up prospects for the development of high-quality and secure information processing systems. In order to achieve goals of the research, the following tasks were set. First one, analysis of technologies for certification and protection of digital content. Second one, development of an algorithmic description of the system and creation of software implementation. Let's talk about technologies used for certification and protection of digital content. The first one is the key snarks. The key snarks is a zero-knowledge protocol that is used to prove that a subject possesses certain information without revealing it and without any interaction between the parties proving and verifying the information. The term the key snarks is an acronym that stands for short, non-interactive, zero-knowledge argument. Here are the basic stages involved in the key snarks process. Actually, it consists of 5 stages. The first one is setup. In this stage, a trusted party generates public parameters. Second one is key generation, where prover generates proven and verification keys. Third one is circuit representation. On this stage, statement is represented as an arithmetic circuit. Next one is prover computation, where prover creates proof without revealing inputs. And the last one is proof verification, where verifier checks proof validity. Socrates is a tool for developing and verifying zero-knowledge proof in decentralized blockchain applications. Socrates allows developers to create applications that can test effect of a property without revealing the input data that validates them. The encryption algorithm is a critical element of the information security system, in particular for our platform, which must process and store private metadata. Choosing a specific algorithm requires a balanced approach, taking into account various aspects of its security, efficiency, and compliance with system requirements. RSA encryption is selected due to its proven track record in secure data transmissions, safeguarding sensitive metadata while allowing for seamless authentication of transactions without compromising anonymity. Let's take a look on system architecture. The chosen architecture for the project is a decentralized application, also known as DApp. It consists of three key components: client, server, and smart contracts on the blockchain. The software is designed to support multi-user functionality, ensure fault tolerance, information security, and scalability. The technology stack includes Vue.js, Node.js, Solidity for smart contracts, Socrates for the key snarks proofs, and MySQL for database management. Now let's take a look at deployment of smart contracts. Smart contracts were deployed as Diamond Proxy. Diamond Proxy is an approach for developing smart contracts on the blockchain that simplifies contract management and updates. The basic idea is to create a multi-contract that contains different pieces of functionality. There are many advantages of using Diamond Proxy, such as unlimited extensibility. Diamond Proxy makes it easy to add new functionality or modify existing functionality without limiting the size of the contract. This is important for projects that can grow and evolve over time. Next one is efficient gas management. Thanks to the possibility of isolating different functional parts, Diamond Proxy allows optimal use of gas, reducing costs when calling only specific functions. Also important to note upgradability without full deployment. Diamond Proxy upgrades are possible without the need for a full redeployment, providing a quick and efficient upgrade procedure. And the last one is ability to make Diamond immutable. If required, Diamond Proxy can be deployed as an immutable contract or become immutable in the future, providing additional security guarantees. On this slide, we can see algorithmic and information support for the implementation of the NFT system, especially sequence diagram, granting access to interact with a smart contract. When interacting with a smart contract, it's first necessary for the user to grant access for this. That is, to send a transaction that confirms the granting of access. The system initiates the transactions. The MetaMask window appears with a prepared transaction, which the user needs to confirm. After confirmation, the transaction is sent to the blockchain, after which the user receives a message depending on the result of the transaction. Now let's talk about the use of the application by user. On the left part of the screen, you can see a screen form of user authorization through MetaMask. Authorization is performed using the MetaMask browser extension. The user enters the website and clicks the login button, after which a request appears for permission to use the account previously selected in this MetaMask extension. If the user has given permission to use his account, a request is made to the server, where a random nonce number of integer type is generated. After generation, on the server, the nonce is sent to the user, who must sign the message in which this random number is stored. This is done in order to make sure that this user is the only owner of this account. After the user has signed the message with a private key through a MetaMask extension, the server checks the validity of this signature. If it's correct, the user is sent an authorization token, which is stored in the browser local storage, otherwise an error message. On the right side, you can see a screen form of the user profile and user-created collection section. On this side, you can see a screen form of marketplace page, where collections available for trading. Next one is screen form of certifying content based on NFT technology. This process consists of 5 steps. The first one is upload picture, then add description, then select collection to which this certificate will belong. First one is add properties, and the last one is add encryption key. This step is optional and used only if there are properties which should be private. On the right side is example of student card as an NFT certificate with private properties of student grades in different subjects. On this slide you can see screen form of generating zk-snarks proof. And on the right side, screen form of verifying zk-snarks proof. We generated proof for English grade, which proves that current grade is greater than 85. After successfully receiving proof, we can verify it and make sure that data is consistent and correct. That's all. Thank you for your attention.